Okay, after you wait for about 1 hour, the vacuum in the pre-pump chamber or the intro chamber should be good enough for you to transfer your sample from intro to the main chamber. So I'm going to show you how to do that. Okay, so you make sure in the system tab. Okay, so the next thing what you need to do is just left click on the image and hold the left key. Then drag this image from the intro chamber to the stage. Okay, then just release it. Then it will pop up the window to ask you to place a sample in the intro. We did that already. Just click OK. And wait for the next pop window to instruct what you to do. So it takes about 1 minute. Okay, so now it said pump intro task is complete. Select OK to continue sample transfer. Just click OK. So you will make another minute to move the stage to place to make it ready for you to do the transfer. Just patiently wait for the next command. So now you pop up window to say, please move transfer arm to transfer position. Select OK only after arm is at the transfer position. So we need to move the transfer arm first. After you see this window, so you quickly come to the machine side. This is a called transfer arm, okay? So we need to move this part, this big block from here to here. Okay, I'm going to do that. So you just need push in, pushing, pushing. And when it comes to close to this ring, you slow down because this is close to the stage, okay? So we slow down, push in all the way until you cannot push more, okay? So the black spot is touching the ring. So that is how you move the transfer arm to the transfer position. And after that, you come here and click OK. Left click, don't worry the ring there, just click OK. Okay, you will pop up the next window, say, please retract transfer arm. Okay, we come back to the transfer arm again, and we need to move this big part from here to all the way to the end. Okay, so we just need to move all the way to the end. And here, this metal pin here is touching this black part, the pin. Okay, so when it touch, the valve will close. You will hear the valve noise. So you come back, click OK. All right. The next few steps is just setup, okay? So if your sample is clean, we should see the pressure come back to -7 Pascal range right away. It takes a minute to move the plate to the stage center. So now, after the next thing is we come to the sample. I'm going to adjust the camera a little bit so you can see better. All right, so let's assume this is okay. Okay, so the next thing, yeah, so after you place this point, if you haven't placed any analysis point, you can do that again here. Just right click and select create point. It will create point. You just place the mouse here. You can drag this point away. To do that, you need to click define point. Okay, you can drag this point to any place you like to do the analysis. Okay, so we don't need this one. We just click delete. All right. So I have 3 samples here. So to do the analysis, we need to drive to the first sample. So what you need to do, highlight the first sample and select drive to position, which you see here. Okay, if you familiar with this part after, I mean, so what I'm going to show you, if you only have 1 sample or anything like that, I would like you to pay a little bit attention. Um, uh, if you have 1 sample, it's okay. But if you have 10 sample or 15 sample, you maybe want to use another method. Okay. Okay. So what I'm going to do now is make sure the vacuum is good. It's -7 Pascal. So we're going to do something called the zero line. It's pretty much like what you do focus in SEM. So to do that, but this is a software, it's automatic. Okay, after you try to position, make sure you try position, and then you come to the software, this side, just click the alarm button. Okay. So after you click the drive position, you see this blue cross come to the analysis point. All right. So it's doing the zero line now. So it takes a minute to turn the E neutral. All right. So I would also like to point out while waiting. So on the lower part of this software, you see the state coordination there. If you see A is automatic doing the zero line during data analysis. Okay, the automatic focus kind of. And we also have E neutral and argon. So if you see A is behind the alphabet A there, that means it's going to do automatically neutralization. And so I would like to keep remind users to check that before you do the XPS, make sure those are in auto. This one, I will come back again, whether you need auto or not, okay? So for most case, I would like user to do at least 1 zero line on 1 sample. Yeah, the rest you can do automatically. Yeah. So after the E neutral now is unloaded, now it's argon neutralization is turned on. So it takes another minute. We can click properties here. Okay, it takes a minute to pop up. So just patiently wait. Okay, in the properties, you see these ZLM properties. It has a graph, a log there. So now it's doing the zero line. Soon you will see a diagram to show you where it will get the highest count. Okay. So in the beginning, you should see some noise. If you don't see any noise, you see now the count of 4 is coming down. The noise normally below 50. So this is a normal. If you only see a flat line there, which means the accurate source is not on. In that case, you need to report to me right away, which means we have some trouble. Okay. So now, see, after you move to a place, you see a significant increase of the count. The software will automatically come back. Okay. And then run in a smaller, final step to See where is the highest peak. When the count is highest, it will mean that place is the optimum position for you to do analysis. So you see it's still increasing. Okay, I think we're going to tell you, oh, here is a peak. Okay, I'm going to your sample is supposed to be in this position in order to take spectrum. Okay, that's cool. That's good. Okay, this is just make sure everything is good. Sometimes you may not be able to find this peak. If this is the case, you maybe see a partial flat line relatively and let me increase the count. If that's the case, we can close this and then we need to come back to the system and right click on the image and select practice. And if you do not see the peak in your view line, but you see an increase of count, which means we just need to set the state to the limit, a little bit larger range, so you can run a little bit higher. So for example, now I don't need 10, but if I would like to be safe, I can put maybe 17.3 there, increase 0.3, because I have another 2 samples. Okay. So the next thing we need to do is we check get a rough spectrum for all these 3 samples. We will do automatic zero line. Okay. After you did zero line, you see the coordination here is showing 16 point something. Here still 15 or 5, maybe in your case. So if that's the case, I mean, this is all the time you need to do. So you need to select update position. What's the meaning of an update position? It will copy the current state position to your point. Okay. See, because we did a zero line, we found optimum position. The state will stay in that place. So you need to copy that place to your point. Say later when I do the analysis will automatically come to this place. All right, so let's move on. We need to do a quick survey spectrum. So we come to the XPS tab. Okay, your source selection should be FXS, fast X-ray. So X-ray setting, we have a long list here. It depends on what you want. Okay, normally I recommend 100 micron, the spot size. If you have smaller feature, you maybe want to go to 20 micron, but normally we use 100 micron. All right. So the other parameter is I don't need to expect you to change much, but you need to change this list. Okay, in the region. Okay, if you want to see the full region, you need to slide this slide here, or you click the button show the full window here. So what you need to do, so first we need the rough scan, so which we call survey spectrum. So to do survey spectrum, I normally for the first survey spectrum, you put 2 switches there, put the pulse energy about. Okay, I'm zooming a little bit so you can see better. So normally we set sweep time to be 2, pulse energy to be about 100. So it's a drop down dialog box here for you to choose. So normally we just give the region is the range. The maximum range is 1585. So okay, so normally it's only worry, but if you have some element, you need to check your element which of your interest on this data book. Okay, we have data book here. Okay, you need to check this book to see your element. For example, today I only have carbon. I maybe have nickel. Okay, if you look at the nickel, okay, you see a spectrum. The highest peak, okay, is about 900. Okay, 900 something. It's below 1,000. But if you happen to have a peak about 1100, We need to make sure the range can cover the peak you're interested. So today we are found the another element I'm interested today is the zinc. Okay, I'm going to take a look at zinc, which is the zinc should be 30. So if you look at the zinc peak, it's about 11, a little bit below 1100. Okay, 12, 1100. But if you want to see better, maybe we go to 1200 or even a little bit higher. So I'm going to put the range here to 1250. So you might set the range first before you adjust low or upper range, okay? So the EV step for the first scan, we put 0.5 EV per step, then we close it. Okay, so that's the setting. Now we double check, we have 1, 2, 3 sample. We need to do the survey selection 4. We also need to do the automatic, okay? The automatic zero line, so which is here, okay, let's say it's auto. So we come to the XPS and select, okay, SPE, that's it. So if you look at the runtime here, it's 1.9 minutes, okay, the runtime. So which means each sample, it would take 2 minutes for data collection. And we also need to do the zero line, take them about another 2 minutes. So each sample takes 4 minutes. So there are 3 samples, maybe takes about 10 to 12 minutes. So we patiently wait. You can do something else first and come back. Okay, so you see the E neutral is on, argon is on. So now we will do the scanning for you. We watch for a minute, then we pause the and then we pause the recording, and then we take a recording to set out the file range, which take another 10 to 15 minutes. So now you see the spectrum are coming, and they say take about 2 minutes. You see a peak here. It's most likely to be zinc. Okay, if you're not sure, I can click ID here. Okay, zinc. So when you do survey spectrum, you will know whether it's a right place for you to take a spectrum. Yeah, this is all zinc oxide, a little bit carbon. The iron pink, these people also interested in iron, which is about 600 something. So you can click element table here and say, where's the iron? Almost no iron. Where's nitrogen? Nitrogen should be around 400. So no nitrogen. So now this spectrum is finished collection. We move to the second sample, which you see the blue cross will move. You see also a yellow window, a yellow frame on this window. Okay. So you move blue cross and move to the second point. So when these spectrum are collected, you can also have a better view in the analysis software called Multipack. Okay, just click this Multipack software. Normally it's on, so it's loading now. So we can take a look at this spectrum we just collected. Just click acquire. You can put ID there too. So we would like to see whether we can see iron and nitrogen. If they don't have there, you can put there. And it looks to me there are almost no nitrogen, almost no iron, but this is very rough scale. It's hard to tell. All right. So this is a kind of this is analysis software. You can do quantification. You can do this ID. If I don't have iron, nitrogen, I don't need to put it on. You can zoom in. Just left click and drag and slide the mouse. You will zoom into this pic. It's very noisy because we only did 2 switch, and it also has large step size. So you can also do quantification if you like. So these are 3 elements. If we take a look, we can select element oxygen, and we drag this red line here. Okay, you will see a dashed line. That's a baseline. So normally for quantification, make sure the dashed line is the right baseline you like. Okay, zinc. So it's a 2p3. So we can drag to here. And then, so this is the right baseline. And the carbon. Okay. So after we set this, we can say, okay, what's the percentage? Okay, we'll give you a table. Okay, to tell you the percentage. You can go to File and Save As. And yeah. Okay. So this is analysis. If you happen you need some fitting, okay? So here's a pic here, but this is not good if we use let me open a file to see whether we can see. I'm open to open my file. So let's see what's here. Oh, there's nothing here. Okay. So for example, now we have so many spectrum. So you can open and find one spectrum. This type of spectrum is fine scanning, so you can see it's much smoother. So maybe we see titanium, maybe. For example, this zirconium. The zirconium, if we want to, you see, as obviously the two peaks here. If you want to fitting, you click fit. Okay, there's so many fitting there, which doesn't make sense. We delete all. The first, we need to adjust the baseline. This baseline is not right. So we click setup and then you adjust the baseline. All right. So after you finish adjust the baseline, after you're satisfied, you just click this, check this again. So this will be your baseline and this is your spectrum. So now to do fitting, we see it obviously has these two peaks. So right click right here and another peak. So if you suspect, we can make this peak wider. It's sometimes the peak are wider than the theoretical. So all right, you can adjust. You can also adjust the height so that it can make it more close to your spectrum. Okay, it's pretty close. Okay, after that, maybe I wanted to put a little bit peak here. Okay, if you see, and maybe a little bit peak here. But this may not be a peak. So for some metal, you will have this kind of tail there. But if it happen to be peak, you can do in this way. That's what I'm trying to do. So you adjust to make sure all are close enough. So I add 5 peaks. Then I just click fit. So you will see the fitting pretty close. If you take a look, there's a table here. It has band 1, 2, 3, 4, 5. So that's the 5 peaks we put. Okay. You will see the position. You will see the fitting good or bad. It's not very good. Okay. The band 3. Oh, where's the band 3? We can click band 3, which is there. Band 4, there, 5. That's the 100% goals is from those two. So the first pick is not very good, but it's okay. What you can do sometimes you want to repeat this process, you say, okay, fit again. Okay. So you maybe see some change. Okay, you say apply default limits and fit again. Okay. So you will be able to see a little bit better fitting. Okay. Still no change, but sometimes you just need to try. All right, so this is how we do fitting. If you like the fitting curve, you go to File and export to S2 format. So you will see your fitting curve. Or you can save as. Okay, so it's a fit. Normally I would say use File export to. Okay, and if you need this table, you can go to View Summary. So this will give you the table, and I go to File and save. Okay. So what we save here is kind of your spectrum, your baseline, your different fitting curves there. Okay. Sometimes it's useful, and after it's finished, you just click Exit. Okay, so you come back. So I did a quick introduction of how we play the software. All right, now this side is ready now. We get all the spectrum we want, okay? If we go to my pack, we open the folder we set out. So it's still under my name. It's October 6th. All right, so we got 3 spectrum there. So we can open one. This looks like that. We open the second one. We can say overlay. If you have similar sample, but if you have not relevant sample, you just want to take a look, you just click new. Okay, so this is 3 spectrum we see. So we do see Number 7, second blue curve. I'm trying to see this problem. This silicon oxide. Okay. This is silicon oxide. All right, this looks good to me. So I just leave it here at the moment. We need to set up the fine scanning. So the element for this case, I'm interested, I go to element table. I'm interested on the carbon mostly, and zinc, oxygen, and silicon, iron. That's it, and nitrogen. So this is the element I'm interested. So I select all the elements there, so I can take a full view. Yeah. So this looks good to me. The sweeps normally for later, if we like a better survey spectrum, I put 20 to itself. Carbon is the element we are all interested, so most interested. So we can give it a little bit more scan there. So you see the carbon peak here. Yeah, just zooming. So you see the carbon peak. So it will, the major peak is about 285 or something because it's carbon nanotube. So we will set up the range maybe around 275 to 300 will be good for carbon. Okay, it's pretty much like this. Okay, so we will start from 275. So we set up, 25. So let's put a 30 sweep or maybe even 40 sweep for carbon. Maybe 30 sweep. And the zinc, I would like to change the zinc, the default were 2p3. I would like to use a zinc 2p. No, they don't have 2p. 2p3 is fine. Okay. Okay. So if we take a look at zinc 2p3, which is here. So if we like to set at a range, but this is where okay, 2p3 is fine. If we want, we can include the 2p1 there too. So if we want, we can set up the range to be maybe 10, I think at most 10, 15, okay? Maybe 10, 13 will be good. 10, 13 to 0.4. So let's take a look. So when you go to 45, 49, if when you go to 49, 13 is 36. Okay, so for the range there, you automatically adjust your upper. So also we need the step size to be 0.05. So for the zinc, we maybe put 33 there too. Okay. How about the other element? Oxygen. Oxygen is here. Okay. So maybe 520 to 540 will be good. You can see. Okay, and the silicon. Okay, silicon and oxygen. We need to put 33 there too. And the silicon is not that critical element. We put 20 there. Iron, put 30 there. Nitrogen, 30 there. Okay, if this is the case, you see this sample will take about if we include all the elements, take about 2.5 hours, which is pretty long. Okay, so yeah, let's fine tune this a little bit. Okay, and the silicon, the default is a 94. So oxygen, we just check the range for all these three. So now we need to check silicon, which is around here, 99. So this is a silicon peak, okay? 95 to 96, 95, 96 to 106. We'll come back to here, 96 to 106. Okay, and iron. Iron almost no peak there, and the nitrogen almost no peak there. So if we take a look at the iron, the place, it should be around 600 something, or 720 something, 700. So this is iron is obvious to me that no peak there. So I also prefer to use iron 2P. We just use the default range, should be okay. So we say we don't have peak there, we put 30 there. And the nitrogen. Okay, nitrogen should be about 400. Also, we don't have. So I know if it's a this is a nitride. So I go to the nitrogen 57. I take a look at the data book. Okay. So if we look at the data book, we have two sides, left side and the right side. The left side is what with the table you need to use because we use aluminum as the phase source. So if you look at nitrogen, the graph is here, but it's a table which is around here on the right side. Okay, so if we for the nitride, okay, the peak will go to around 404. Nitrates will go to 408. Okay, so it's a large range. So when you set a range, especially for this case, we don't have a clue where it's supposed to be. So I think the default range should be okay. So we just leave it there. Yeah. Okay. So this is a setting. So now I'm going to show you how to set up queue. We don't need, because all these samples now are zero line. We don't need a zero line again. Okay, so we click zero line up. So yeah, another thing before we go to set up everything, is, yeah, you maybe want to reposition the place, for example. But for this case, it's a big piece of wafer, have no worry. But for your case, sometimes you need to use Ssi Imaging, which you do here. Okay, I'm going to show you briefly how to do it. Just click Start Exercise. It takes a minute to start. Okay, so we have a slow mode and fast and throttle. If you click the drop box here, okay, it started now. So we now in slow. So if you look at around, if you in the future, if you have small region you want to focus on, you will see something like SEM image. So if I want to see this point, okay, you see a little hole there. So I just left click on that hole, it will come to the region of center. So we need to take some time to update. So you can see that come to the center of the screen. Okay, so that's how you position it. And after that, you just click update position to update to this location. So you can analyze it. You can also right click here and save and add to position list. Okay, if you, that's what you like. And then you will be able to see your image. Okay, you say, oh, I want to do analysis of this point, and I want to do analysis of another place. We need to do comparison to see the difference. So this is how you set up. Okay, we don't need to do for this session, so I'm okay. So after you position it, that's it. You can also drive to the next point by make sure the define point is on. So you can highlight that point, select drive to position. Then we'll drive to the next point. Okay, then allow you to adjust the position again. So you don't need to turn off this to move. Okay, so you see updating. It takes some time to update the image. It's a little bit slow. It's supposed to be this way. I normally don't use fast because it's too noisy. We use slow mostly. So this uniform, because my sample now is just a film. But yeah. So this is how we do the Ssi imaging. After you position next point, you update it. Okay. So okay, we don't need for this sample, we just stop it. I just click this off. So all right, so the next thing I'm going to show you is set up the queue. So we have 3 samples. All these samples you have, you're interested at different elements. So you don't need to set up all. So I'm going to set up sample 1, for example, sample 3, point 1. So for point 1 is zinc oxide sample. So I will say, oh, I would like to make sure the survey, the percentage are all same. The step EV per step for this element all same. Okay, the switch, we put it right. So we are interested on the zinc, oxygen, okay, oxygen, silicon, iron, nitrogen for this first sample. Yeah, we just need add Q. Okay, if you add Q, you see a long list there, just delete all, click add Q again. So this will be a sample one. We are going to interested on this element. Now we check sample two. Okay, we set up sample two. Carbon nitrate, no, carbon nanotube. So I'm going to do zinc off. Okay, I need carbon. Maybe I put 40 switch there for the carbon. Okay, so I add Q. So oxygen still there because silicon oxide. So I'm going to go back to here and say add Q. Some Q, I'm interested in this element. And sample 3. Okay, so we need all these elements. So I'm going to add Q. So after that, okay, I normally also suggest user to collect a survey spectrum with a tiny switch. Sometimes you need it to see what's really in your sample. Sometimes maybe you see some element which you are not expected to be there, but it's there. Okay, so we do a survey spectrum Q. So we add the Q. So now if we take a look at this list, we will do sample 1, 2, 3. Sample 1, we will see different elements. We don't need to do the zero line because we did in the beginning. Everything else are the same. So now I highlight the first job and click start. Okay. Yeah. So then we we can watch. Oh, you just leave the room and come back to get your data the next time. But please also put the actual machine time, which is when you set up, you have a runtime there for each sample, how long it takes. You put all this together, okay, and add it up and put, oh, this is my total machine time. So we will put it in the QR code, the log, the comment, so we can note down how much actual time used. So we don't mind you use after working hour. You just leave the room, let it run. You get the sample next day. It's okay. If you don't need to, yeah, okay. If you only need 2 hours, 3 hours, choose the morning time. All right. Okay. We'll see you when it's ready to pick up the sample.